All right, question number 6. We want to know what is the domain of f of x and where is f continuous. So given this function, what makes the denominator 0 is a 5. So if we were to plug in 5, we would get 0, which would make this not continuous. So the domain would be all of x except for 5. So we cannot use 5. And then part 2 says the function f is continuous where, and it's going to be at x is not equal to 5, so everywhere except for 5. Number 7, we want to determine whether the function is continuous at a, and we're going to use our continuity checklist. Okay, so if we were to think about what this function looks like, okay, we have a square root function. So just a rough sketch. Square root function starts at 0 and then kind of curves out like so. Kind of like a half a parabola turned on its side. Now the square root minus 7 is going to shift it right 7 units. So 1, 2, 3, 4, 5, 6, 7. So that means this graph starts at 7 and then goes this way. Same shape, just got shifted over. If we were to plug in 5, so if I say square root of 5 minus 7, and I evaluate 5 minus 7, it's going to give me the square root of negative 2. Well, you can see that this graph is not defined at 5. I don't have a y value associated when x is 5. It only starts at 7 and beyond. We cannot take the square root of a negative, so it's going to be imaginary. So that won't exist. So this point is not even defined. So when we wanted to know if this is continuous and use our checklist, the first thing we get is that the function is not continuous at 5 because it says although it's defined, which it is not, so that's not the one. The function is continuous, nope. Says the function is continuous, nope. So we're going to say the function is not continuous at a equals 5 because f of 5 is not defined. That's the very first thing we get. It's not defined.